A very good morning to everyone. This video is about a metallurgical coke manufacture or synthesis by Otto-Hoffmann method. So, metallurgical coke. So, what is meant by a metallurgical coke? A metallurgical coke is generally a carbon-rich material in which it is having a high percentage of carbon content. It's produced from bituminous coal in the absence of air, and it will be act as a reducing agent, that is reductant in metallurgical industry, which is having a macroporous structure. It means a carbon material which is having a macroporous structure. It means the porous structure is very big in size, and it is often called it as met coke or blast furnace coke. From the starting material bituminous coal, the carbonization process is happening in the absence of air at very high temperature up to 1200 degrees centigrade, and it will be convert it as coke material. Coke is nothing but a carbon rich with a big porous structure. Okay, the percentage of carbon in this material is averagely around 70%. Of course, the physical property shows a high porosity in nature. Carbonization reaction would be happening, everyone knows that, in the absence of oxygen. Okay, so the prepared material would be a very useful material for reducing agent, okay, in several chemical reactions. The physical nature, such as a macroporous structure, when it is combined with a composite material, would serve as a good mechanical strengthening material, and the thermal energy is also very good. So what would be the advantages? The valuable byproducts such as ammonia, coal gas, naphthalene are recovered, which would be further useful in the industrial synthesis. The carbonization time is very less in this reaction. So heating is done externally by producer gas. The reaction is shown in the picture. So this is the setup of Otto-Hoffmann's byproduct oven. Initially the chambers is having a coal material, so air and producer gas starting material is supplying inside the hot regenerators. The hot regenerators is the one which supplies equal amount of heat homogeneously by dissipating the heat equally. That's his role, and it is supplying to the chambers which is loaded with a starting bituminous coal material, and it is subjected to the carbonization through a silica bricks inside a chambers. So that would be withstanding the around more than 1000 degrees centigrade, which would be further subjected to the carbonization reaction, and the remaining gases would be flew to the side towers, and the byproducts are being recovered. On supplying liquid ammonia, we are getting tar. On supplying water, spraying the water, normal water will get ammonium solution. Cooled water spraying will give you a naphthalene material, and petroleum, when we spray to the coming gases after the reaction, will retain the benzene material. And finally Fe2O3 powder spraying will leads to H2S byproduct material, and after these separation done, you will be getting a coal gas material at the end. This is Otto's Hoffmann byproduct oven. so which in turn is producing valuable byproduct material. Those byproducts are useful in several industrial applications here. So in order to increase the thermal efficiency of the carbonization process and recover the valuable byproducts such as naphthalene, ammonium solution, benzene, coal gas, etc., here it is important to do Otto-Hoffmann method. The components are silica chambers having supposed to supply equal amount of energy, heat energy. So this would be having 10 to 12 meter long, 3 to 4 meter height, 0.45 meter wide. Each chamber is provided with a charging hole at the top. Gas half take valve and iron door at each end for discharge coke. Mixture of CO and H2 will be supplying at burn and 1200 degrees centigrade, which in turn gives a coke material with byproducts. Air and gas are preheated by sending through second and third hot regenerators, and hot flow gases produced during combustion will be a pass through 1 and 4 regenerators. When the process is completed, the coke is removed and it would be quenching with water. Here within 1 day, maximum 20 hours, the reaction is getting completed, and almost you are getting more than 70% of carbon material. That's why it is popularly called as carbon rich material. Tar, ammonia, naphthalene, H2S, benzene, etc. are the byproducts that can be achieved from here. So thank you so much for your valuable time.